Okay, welcome back to today's topic, our next topic. Actually, it's the same topic. We're still doing this general second degree equation. We left off on page 34. We just finished example 2b on that page. And now we're going to go ahead and look at example C and example D as well. We'll get those two completed in this video right here. Now, the first thing again I'd like you to note is for C, look carefully at the equation that we have here. Now, I know that they actually went ahead and told us it was a hyperbola, but they didn't really have to do that because if you know what you're looking at, if you understand completely the equation, you could have told it was a hyperbola anyway. I can see that the x part is squared. It contains a y squared. So it's not a parabola. I can see that in between the two, look at that. There's a negative sign, a minus sign. So one of the terms is positive, and you can think of the other term as negative if you like. So that means that we definitely have a hyperbola here in this situation. Okay, so here's what we're going to do. We're going to attack this equation, this general equation, where we have to find things like the center and the foci and the vertices and the equations of the asymptotes. I'm going to leave all that for you to try, but we're just going to change over that equation from the general form back into a form where we can answer those questions, right? So here's what we do. We basically start it the same way that we started the ellipse. I'll put together my 4x squared, like so. And what's the other? Okay, plus 32x. So I'll put those two together. Now remember, I have to remove that 4. And then I go minus, all right? And then I put in brackets. Now be careful here. Watch what's going to happen. I start with y squared, all right, because remember, it is subtract y squared, and that's what I have right there. But if I were to put down plus 10y as my next term, I have made an error. I have made a mistake. And the reason I've made a mistake is because look what's in front of that bracket. Look what's in front of that plus 10y. There's actually a minus sign, isn't there? Right? So if you were to distribute that negative sign throughout the brackets, you'd end up with minus y squared, which is okay. That's what you were supposed to get. But you'd also end up with minus 10y, right? That's not what we have in the equation. We actually have plus 10y. So in the case of a hyperbola, for the second set of brackets, because it's always going to end up with a minus sign in front, there's something else you need to remember to do. And that something else is this. That sign right there, that plus 10y, you always have to change that sign into its opposite. Only for the linear term, though, only for the middle term. So what I'm going to do is take away the plus, and in its place, I'm going to put minus 10y. Now, look what happens if you took this negative that was in front of the brackets. Now what would happen if you distributed it through that set of brackets? Now you'd end up with minus y squared, and that's okay. That's what you were supposed to get. But now the minus 10y would turn into plus 10y. And sure enough, there you go. Everything is now fixed. Everything is okay. That really is plus 10y. But you have to remember to do that in the case of a hyperbola. Forgetting that step, you're going to get everything else after that wrong. So I'll put bracket there. And by the way, notice that in this case, the coefficient of the y squared is just 1. So really, there's nothing there to remove from that second set of brackets anyway. I'll take my plus 35 and I will put it on the right side and I'll get negative 35. Okay? All right, now, first set of brackets right there. The 4 has to come out in front. No choice. It got to come out. So I divide the 4x squared by 4 and I get x squared. I divide plus 32x by 4 and I will get plus 8x. And now I'll leave a little space because I'm going to complete the square there in my next step. And then I go minus y squared minus 10y. Remember, there was nothing to remove from that second set of brackets, but I'll leave a little space on the end, and I'll just go equals negative 35. Okay, you ready? Are you ready? Watch this now. First set of brackets. The middle term is 8. You take half of 8, you get 4. You square 4, you end up with 16. So we must add 16 inside that first set of brackets. But remember, doing that, I've now thrown off my equation. My equation is no longer correct. It is no longer valid. I have to fix that. Now, I did write plus 16, yes. I wrote plus 16 inside that set of brackets, but remember, I didn't really add 16 because there's a 4 in front of that, you see? So I really added 16 times 4, which is 64. That's what I really added, in essence. So to refix my equation, to rebalance my equation, I come to the other side, to the right side, and I put down plus 64 there as well. It's like a seesaw, right? If you had a seesaw that was nice and balanced, and suddenly you added 64 kilograms to one side, well, your seesaw is not going to be balanced anymore, is it? So to rebalance it, you'd add 64 kilograms to the other side as well. All right, now, there's a little more to it than that, but in a nutshell, that's basically what you do. Now let's look at the y squared minus 10y, okay? Half of 10 is 5. You square that 5, and you get 25. So right here, I have to go plus. It's always plus on the end, remember? 25. Now, again, I have fooled up my equation. I've thrown off my equation. So I've got to do something. I've got to add something to the other side to rebalance it. Well, the thing is, did I really add 25? I wrote down plus 25, but did I really add 25? And the answer is, look at what's in front. Look at what's in front of that bracket. People, there's a minus in front, right? Well, that minus, if I were to distribute that through the brackets, or think of it as a minus 1 multiplied by positive 25, look at what I really did. I really subtracted 25. So if I want to rebalance that equation, because of what I just wrote down, that plus 25, I come to the right side and I write down minus 25, because in essence, that's what I did to the left side. I subtracted 25, so I had to subtract 25 from the right side as well, okay? Little things you had to keep in mind, everybody, when you're doing these calculations. All right, let's see what we have next. These two sets of brackets are now, they're perfect square trinomials. You forced them to become perfect square trinomials. So you should be able to write both of them as the square of some binomial. And the first one, you're going to have x, sign in the center right there is a plus, right? So this is going to be a plus. And the square root of 16 is 4. There you go. There's your first set of brackets. Second set, all right, let me see. You're going to have a y, and the sign in the center is a minus, so this is going to be a minus. And the square root of 25 is a 5. And then you write equals. Over on the right side, let me see. You could just grab a calculator and type those numbers in if you like. And I'm pretty sure you're just going to get 4. Negative 35 plus 64 minus 25. We're almost done. Not quite, though, because the 4, remember, for a hyperbola, that should be a 1, shouldn't it? So you divide everything by 4, everything by 4, everything by 4. They'll cancel there. So again, for the first term, for the x squared term, you're just going to have a denominator of 1. And you could write a 1 there if you want, or you could just leave it out. It's up to yourself. The y minus 5 squared over 4, that's fine. There's nothing there to reduce. And of course, over here, 4 divided by 4, you're just going to have a 1. So your final answer, the hyperbola now, is going to be x plus 4 all squared. You can put that over 1 if you want, but you don't really have to, but you can. You can put over 4 if you like, over 1, I mean. And then it's minus, and then the next set of brackets is going to be y minus 5 squared over 4 equals 1. And there you go. Now you can find out, excuse me, Now you can find out all of those things, all of those points, and you can tell things about the graph, like does it open up and down, or does it open left and right? This one here is actually going to open left and right, isn't that right? You can find the center is at -4, +5. You can find your foci, your vertices, and your covertices, equations of the asymptotes. All of that you can find now because you've changed your equation back, function, you've changed it back into that standard form. All right. So you try to find things like the vertices and the foci, right, and the covertices and the asymptotes. Check your answers on D2L. Make sure you're getting them correct. I'm going to move on to part D here next. All right, I'm going to move down to part D. And this is the last of the examples. After that, I believe most of it is practice problems. So I'm going to leave all those for you to try. Notice now some of them on page 35, it also says example, but you should be able to easily get those, I think. Oh yeah, you should be able to easily change those on the next page 35. I'll have a look at them before the video's over anyway. All right, here we go, part D. Part D. Now again, they had to come out and tell us it was a parabola, didn't they? Well, I kind of wish they never, because we should have been able to tell it's a parabola to begin with in the first place. Now I can definitely see this is general form. I can see an x squared there, but do you know what? I don't see a y squared there. So only one of the variables is squared. The other one is just there basically to the power of 1. And that's how we know that it's a parabola. All right, that's definitely a parabola. So here's what we're going to do. We're going to take this equation right here, and we're going to write it in the form that we were seeing for parabolas, where the squared part is on the left. Any constants would be on the right, along with the non-squared part, the linear term. Okay, so let me see. Well, which variable is squared there? All right, well, the x is squared, isn't it? So obviously, if the x is squared, that's going to end up being the binomial squared somehow. So I'm going to write x squared plus 6x, and I'm going to leave all of that on the left. Everything else, all of this stuff here, I'm going to throw over on the right side. Now leave a little space there because remember, you're going to complete the square there. If there was a constant in front of the x squared, that would have to be removed as well. All right, so let me see. What have I got? I got minus 8y minus 9. Make sure you get your signs right. Okay? Now what? Now what? Let me see. All right, complete the square here on the left side. Half of 6 is 3. 3 squared, that becomes a plus 9. Okay, now remember, by writing plus 9 on the left, I've thrown my equation off. If I want to rebalance my equation, I have to do exactly the same thing to the right side. So I'll come over to the right side and go plus 9. Okay, something nice happens there. Now watch what you have. This just becomes x plus 3 squared, right? That's what that trinomial would become. You forced it, remember, to become a perfect square trinomial. And over on the right side, now look at that, your 9's cancel. Now that won't always happen, but it sure did in this case. And all you're left with is negative 8y. All right, well, you know what? That's it. That's fine. That's good. That's the form we were seeing parabolas written in back when we did the topic of parabolas. Now you can certainly find things like the vertex. Okay, the vertex here. I mean, this is simple stuff now. After the x, I have a plus 3, so it starts with a minus 3. What's after the y added or subtracted? Nothing. So there's my vertex. And by the way, let me just very carefully look. Negative 3 and 0 would be about right there. There's my vertex. And according to the form of the equation, I see the x is squared, so it's either opening up or down. But the constant, that 4p, remember, in this case, it's a negative, isn't it? So this one is going to go something like that. It's going to open downward. All right? So now your focus is, of course, inside somewhere. It's inside, approximately there. And your directrix, of course, is up above on the other side, a horizontal line, like so. Now the only thing is, to get those, you need the p. Well, folks, look right there. Remember when we did this? You set that equal to 4p. You can make it negative if you want. I usually just go positive because it's a distance. So I get p is equal to 2. So 2 blocks down from negative 3, 0, there's your focus. And that's going to be, I mean, if you look carefully at that graph, that's going to be negative 3, negative 2. There's your focus. Negative 3, negative 2. Your directrix is actually 2 blocks above the vertex. Make sure you write y equals, because remember, it's a horizontal line. And 2 blocks up from 0 is y equals 2. There's your directrix. Why did I write directive? That doesn't make sense. I must have been on autopilot that time. Your directrix is y equals 2. Okay? Now, that's it for the examples on page 34. Now, I know here on page 35 it says example 2. I'm pretty sure you should be able to take all of these conics anyway and write them in standard form, the forms that we're used to seeing it. In the first one, you probably should bring that negative 2y squared over to the left side. In the second one, I'll tell you what, throw everything over to the left side. Well, except maybe the 3. You probably leave the 3 on the right. But throw everything to the left and see what you get. What kind of a shape will you get? C, okay, that's already in general form. That looks pretty good. D, do you recognize D? Now, they're not going to ask you to graph D. I'll never ask you to graph D. But what is it? What is that? Well, about the only thing you could do there is, if you bring your 36 over, you get x times y equals 36. And that, everybody, that's the simple form of a hyperbola. Remember doing that? E, multiply through the brackets by 4, group everything on the left, see what happens. Practice questions on page 36. Okay, identify the conic and write it in standard form. Okay, I'll leave those for you to try. B, multiply that out, everybody. Multiply that out. Throw everything over on the left and see what happens. Part C is already in general form. That one looks okay. Part D, let me see. Part D is interesting. I'm going to let you try that, but here's a little hint. It's not one of the 4 conic sections we've looked at. So you sort of multiply everything out there, see what you have left, see what you're going to have, and then identify it. For E, now ordinarily, look, if I saw y plus 1 squared in an equation, I would think that was part of the standard form of it, but it's not, because look what you have there. You have plus y squared. So what you need to do for E is actually multiply that out on the left. So multiply x or y plus 1, sorry, by y plus 1. See what you get. Then take all of these terms there, throw them over with the result, and see what happens. F, I'm thinking F is a hyperbola. I'm going to let you try that one as well. So anyway, that's it for this lesson. We looked at some of the examples of changing from general form back into standard form. Please try those practice questions on your own. Keep checking the answers in D2L. All the solutions have been posted. If you have any trouble, make sure you pop me an email, okay? And I'll certainly get back to you. All right, so that's it for this topic. We have one more thing to do, and then we're finished unit number 3, okay? So I'll finish this video right there. Bye-bye.